Okay, gentlemen, we're going to work on 2.6 days, day one distance time graphs. I know I alluded to this a little bit in the last lesson, but we'll look at it in a little bit more detail today. So true, false indicate whether the statement is true or false. A hypothesis is a statement that is always true. And we didn't cover some of this in 2.1 and 2.2 because we pared down the lessons for this chapter. However, I'm going to go through some of these answers just for the sake of it, but I know we didn't cover this, so you don't have to worry about this too much in terms of an assessment. This is our COVID 2020, 2021 year. So for you guys, it doesn't apply. If somebody's watching this video in the future and we're past COVID, this is your homework. You still need to know this stuff. All right. So a hypothesis is a statement that is always true. You want to watch out for these things, right? Always, these absolutes. So that's false, right? It's not always true. A hypothesis is something that you test to see if it's true. A scatter plot is a type of graph that can be used to find a relationship between two variables. That is true, right? You look at the scatter plot, see if there's a trend, and you can tell if the variables being studied are related, like the higher up the ramp you are on a skateboard and the stopping distance, or the speed of your vehicle and the stopping distance, or the number of hours you study and your grades, that you see if there's a relationship between these variables. Your hypothesis might be that the more you study, the higher your grades, right? And you're going to test that hypothesis. Is your hypothesis always true? No, not necessarily, right? So Statistics Canada is a good source of primary data. That's false, because primary data is data you collect yourself, right? Statistics Canada has a repository of data that you can access, but you didn't collect it yourself. So that would be secondary because you didn't collect it yourself. So it's not a good source of primary data. For our purposes, the 2020-21 group here, that's number 2 is probably something that we've covered, right? That you need to know. A sample, you don't know about samples. We didn't learn about that yet this year. So a sample is often surveyed to verify a hypothesis. Just to fill in the blanks here, okay? Scatter plots, this is important. Scatter plots and line graphs can be used to analyze how data are, I should have put are, how data are related. Okay. Some nonlinear relations, if it's nonlinear, you would be using a curve of best fit. That came up in last day's handout in terms of definitions, right? Multiple choice, which of the following is a systematic random sample? Again, we didn't cover this, but this would be the systematic random sample. Why is it systematic? Well, it's random because every 10th person is selected. Okay, we don't know where we're going to start, but every 10th person selected. But a name is randomly selected from a list of a store's customers. So that means that the fact that it's random, or how is it random, is because if a name is randomly selected from the list of the store's customers, then everybody has an equal chance of being chosen. Okay, so that's why it's considered random. If not everybody has an equal chance of being chosen, well, then it doesn't count. It wouldn't be considered random. Anyway, so that's a systematic, and the reason why it's systematic is because you start there at a random person and get every 10th person before and after that, and so then everybody has a chance of technically being potentially having the opportunity to have been chosen. So the learning goal today is to determine how an object is moving from a distance time graph. So by looking at the distance time graph, we should be able to tell what's happening. A distance time graph shows an object's distance from a fixed point over a period of time. Okay, and so this is talking about distance increasing with time. So we don't have numbers here. It's not saying 1, 2, 3, 4, etc. But we do know this is a certain distance from somewhere, right? 0 would mean if you're 0 meters or 0 units away from something, that means you're at the place. If 0 is home, then right now at this point here, you're away from home. I don't know how far, but you're away from home. I know that much. So we're going to talk about this very generally, obviously. If you're away from home, if this is time, as time is passing, what's happening? Your distance is actually, so by this point, now your distance is here. You are now farther from home. Okay, so as time is passing, your distance from home is increasing. So your distance increases with time. Now, whenever you have a linear relationship, when you see a straight line, that means you're traveling, or the object or the person or whatever it is traveling at a constant pace, kind of like a staircase, right? You're constantly going at, that's how you get a linear relationship. Remember in last day's handout, we talked about how can you tell based on a set of data, just looking at coordinates, how do you know that it's linear? Well, because the y values change consistently as x changes. So if x goes over 1 and y goes up 2, over 1, up 2, over 1, up 2, that creates a linear relationship. But if you go up 1 over 3, up 1 over 1, up 5 over 2, well, that's no longer a linear relationship. Okay, so the reason when you see the reason why I'm saying it's a constant pace or a steady rate is because it's a straight line. So this person or whatever it is going away, right? And then the distance is decreasing. If the distance is decreasing, think of it like a car parking, right? As time is passing, it's getting closer to the car behind it, right? Or as time's passing, you're getting closer to home if you're walking toward home. Okay, it's also walking at a steady pace or a constant rate. Okay, and then here when the line is flat, the distance is constant. That person or that object, say you're pretend you're far from home, you're at a certain distance from home. Well, as time is passing, you're not moving. So it could be that you sat down on a bench, time's passing, or sitting on the sofa, right? This could be you a distance from the TV, you're walking farther from the TV, you sit on the sofa, or sorry, you walked farther from the TV, then you walk back towards, sorry, let me start that again. You're walking away from the TV, then you walk closer, there's a sofa, let's say far from the TV, but there's another chair that you want to sit at. So you walk back toward the TV. So away from the TV, going that way, then back toward the TV, and you stop at that chair that you want to sit at. And now you're sitting. So time's passing, you're just sitting there. Okay. You didn't get, if you come all the way back down, then you'd be at the TV. Right. Okay. So that's describing a distance time graph. State which phrase best describes each statement, each segment of this distance time graph. Justify your answer. So where is there no movement, right? The object or the person is not moving. Well, clearly that line right there between C and D, nothing's happening. Time is passing, but there's no movement. So for that one, we would say C to D. Where is there the fastest movement, slowest movement, and backward movement? Now, backward movement means you're walking back towards an object. If you're walking back towards an object, or back towards the TV, in this diagram, right, if we start at 0, for example, you're home, you're going away somewhere at a constant rate, then you're increasing speed, right? Your slope is getting a little steeper, right? If your slope is getting more steep or less steep, you're changing your speed, right? Because in a short period of time, if I have a really steep line, that means in a short period of time, you're traveling a lot of distance, okay? So the steeper the line, the faster you're traveling. Well, so you're going far away from home, you're walking away from home or traveling at a constant pace, but then your pace increases, and you're still going at a constant pace, but at a faster one. Then you're stopped for a bit, and then your distance is decreasing again, and so you're coming back toward home. So between D and E is the backward movement where you're going back toward home. What is the fastest movement? Well, to find out the fastest movement, you have to see, look what happens with the time. Let me try a different color here. Look what's happening with the time here. And over 2 units of time here in green, we've traveled 1 unit of distance. So 2 units of time, 1 unit of distance. Okay, for that segment from A to B. Let's look at from B to C. Over 2 units of time again, we've now covered 1, 2, 3 units of distance. So that's faster, right? Over the same amount of time, you've covered more ground, or you've gone even further. Then here to here, there's no movement. We already talked about that one, so we're not going to count that. And over here, you've over 1 unit of time, you've covered 2 units of distance. Well, that's pretty quick, right? If it's 1 unit of time for 2, if that were, oops, sorry about that. If that were 2, actually, we don't want that right now. That's funny. Okay, so if this were 2 units, another one, then we would have gone up 4. So that's the fastest movement there, right? You've gone up 4. Okay, so that so far is the fastest. So D to E, not only is it backwards movement, if it's running back home, someone forgot something, maybe forgot to lock the door and you're running back home. Where would the slowest movement happen? It seems like A to B is the slowest movement, right? Because it traveled 1 unit of distance over 2 units of time. So we're gonna say A to B for that one. All right, hopefully that makes sense. This should start making a little bit more sense. A to B, okay. describe the motion shown in each distance time graph. So you could have different explanation for what's happening. If you're looking at this one and an A, what do you have there? You've got a line just horizontal, not going anywhere. So as time is passing, the distance is still constant. So that could be you again sitting on the sofa, okay, watching TV. Let's see if I can fit that in here. Sitting on the sofa, watching TV. Okay, that could be the first one. The next one, you're traveling at a constant pace away from something. Okay, so it could be you're walking to school, right? You met your friends in the next block. So you're a certain distance from home, right? And so you could say from a certain distance from home, you meet a friend and walk to school at a, this is important, constant pace. Or speed. Speed is probably the better word there, okay? I'm gonna try and space that properly. Don't you just love when Word does that? There we go, nice. Okay, so from a certain distance, or I should say at a certain distance from home, probably be better. At a certain distance from home, you meet a friend and walk to school at a constant speed. All right, here, this is interesting. So the distance is greater, and then as time passes, the distance is decreasing. So you could be walking home from school at a constant pace or constant speed, I might say, right? Let's see if I can fit that in there. That might not fit. I'm going to bring this up if I can. That's not what I wanted to do. Let me see if I can fit that in there. Yeah, so walking home from school at a constant. I should put that in capitals for you because that's important. Okay, and this one here, okay, this one's a little bit different. This might bring us to the next page, unfortunately. So let me just tab this whole thing down. All right, there we go. That might make life a little bit easier for us. All right. So for this diagram here, there's a lot going on in distance time. So you're walking or something's moving at a constant pace away, then back, and then there again. So you could be going for a jog at a constant pace, then you turn toward home and you stop to tie your shoelace, right? You could be walking, like I said, towards the TV or away from the TV towards a sofa, and then you go back towards the TV to a seat that's closer and stop and sit down. It could be a number of things. So you can describe that. You can really describe that on your own. I'll just call this one C, and change that. D is going to be, so you could also, I'll use the going for a jog one, going for a jog at a constant pace. And taking a rest on the way back toward starting point. Okay, that's probably the easiest way to put it. Or you could say something like going for jog at a constant speed, turning back toward home at a constant speed, and stopping short of the starting point to tie your shoe. Pick up your cell phone or stop to make a phone call, something like that, okay? Because you didn't come all the way back to where you originally started. In order for you to come back to where you originally started, you would have to come all the way back to here, and then, right? So that would be our starting point in line with our distance, but it's not, okay? All right, so I hope that was helpful. And that's it. See you in class.